Hi everyone, welcome back to Coding Fab. In today's lesson, we're diving into Python basics, the foundation of your programming journey. We'll start with the print function and comments, then explore how to work with variables and casting. After that, we'll walk through operators and dive into essential data structures like lists, tuples, sets, dictionaries, and strings. Then we'll cover how to make decisions with if-else statements, how to repeat actions with while and for loops, and how to create reusable code using functions. Finally, we'll introduce classes and how they help you build more structured programs. Okay, let's get started. One, what is print? The print function is used to display output in Python. It sends the specified message or value to the console. It's mainly used for debugging, displaying results, or providing user feedback. The simplest way to use print is to provide a string inside the parentheses. The text "Hello World" is a string and must be enclosed in double quotes or single quotes. The print function outputs it to the screen. 2. Printing numbers. You can also use print to display numbers. Numbers don't need quotes because they are treated as numerical values. You can print both integers, whole numbers like 42, and floats, decimal numbers like 3.14. 3. Printing multiple values. Print allows you to print multiple values at once by separating them with commas. The comma automatically adds a space between values. You can mix different data types like text and numbers. It makes displaying information easier without manually adding spaces. 4. Printing with custom separator. By default, print separates values with a space, but you can change this using the separate parameter. The separate changes the separator from a space to a hyphen. 5. Printing with custom end. By default, print adds a new line after printing. You can prevent this line break by using the end parameter. End replaces the default new line with a space, so the next print appears on the same line. You can use it when you want to print on the same line instead of separate lines. 6. Printing variables. Instead of printing just text, we can print variables. Variables store values like a name or age. Print can display these stored values. The details of variables are explained in a different section. 7. F-strings. Formatted strings. Using F-strings makes printing more readable and powerful. The F before the string allows us to embed inside curly braces. They make it more readable than using concatenation or multiple commas like this. 8. Special characters. When printing text, we sometimes need to include special characters like new lines, tabs, quotation marks, or backslashes. Python provides escape sequences to handle these situations. What is an escape sequence? An escape sequence is a combination of characters that starts with a backslash and represents a special character. The \n escape sequence creates a new line inside a string. Why use \n? It helps separate text into multiple lines without needing multiple print statements. The \t escape sequence adds a tab, wide space between words. Why use \t? It helps align text neatly, like when displaying tables. If you want to print a quote inside a string, you need to use an escape sequence. \single quote is for single quotes. \double quotes is for double quotes. If you need to print a backslash, you must escape it by writing 2 backslashes. That's it for this section on the print function in Python. Let's quickly review what we covered. We learned what print is, how to use it with different types of data, how to format output, and how to handle special characters using escape sequences. These are foundational skills that will help you build more complex programs as you continue learning Python. The best way to get comfortable with print is to practice. Try writing different print statements, experiment with formatting, and see how you can make your output more dynamic. Small exercises like this will strengthen your understanding and prepare you for bigger coding challenges ahead. One, single-line comments. Comments in Python are lines of text that are ignored by the Python interpreter. They are used to explain the code, make it more readable, and help programmers understand the logic behind it. Comments are not executed, meaning they have no impact on how the program runs. First, single-line comments. A single-line comment starts with the hash symbol. Anything written after hash on that line is ignored by Python. It's useful for explaining a specific line of code, temporarily disabling a line of code for testing. 2. Multi-line comments. Second, multi-line comments. Python doesn't have a built-in multi-line comment syntax, but you can use triple quotes to create a block of text that behaves like a comment. It's useful for writing detailed explanations, temporarily blocking out large sections of code. 3. Commenting out for debugging. When it comes to debugging, comments can help you disable parts of the code to identify errors and isolate issues. This is a simple example. Let's say we have a function that calculates the sum of two numbers, but something isn't working correctly. First, let's identify the issue. We only want to print the sum, but an extra multiplication result is appearing in the output. Next, let's comment out the suspicious part. In this case, the second print part looks suspicious. Finally, run and check the output. Now the output is correct. By commenting out the unnecessary line, we ensure the function only performs what it's intended to do. This helps in debugging by isolating and fixing the issue without deleting the code in case we need it later. That's it for this section on comments in Python. I hope this gave you a clear understanding of how to use comments to make your code more readable, organized, and easier to debug. The best way to improve your coding skills is by writing clean, well-documented code. Try adding comments to your own projects, explain your logic, and use them to troubleshoot when needed. A little extra effort in commenting now can save you a lot of time later. One, what are variables? Variables are containers that stores data such as a number, text, or a list, which can be used and updated throughout your program. In Python, you can create a variable just by assigning a value using the equal operator. No need to declare a type. Python automatically determines the type based on the assigned value. 2. Naming rules. These are the basic rules of naming variables. 1. Must start with a letter, A to Z, or an underscore. This rule ensures consistency and avoids confusion when using variables. The underscore is sometimes used for private variables in Python. Private variables are explained in another section. 2. Cannot start with a number. A variable cannot start with a number, but numbers can be used later in the name. 3. Can contain letters, numbers, and underscores. Only letters, numbers, and underscores are allowed to maintain consistency across Python programs. Hyphens are interpreted as subtraction, which leads to errors. 4. Case sensitive. Python is case sensitive, meaning that uppercase and lowercase letters are treated as different variables. 5. Should be descriptive and use snake case. Variable names should be descriptive to make the code readable. In Python, the recommended naming convention for variables and function names are snake case, where words are separated by underscores. 6. Avoid using Python reserved keywords. Python has reserved words that cannot be used as variable names such as class and if. Also the name of a built-in Python function such as sum that calculates the sum of a list or iterable. It can cause unexpected errors in your code. 7. Keep variable names meaningful to improve readability. Variable names should be self-explanatory. Avoid single-letter names. 8. Use consistent formatting. Snake case is the standard for variables in Python. Following a consistent naming convention improves code consistency across projects. 3. Updating variables. A variable in Python can be updated at any time by assigning it a new value. Since Python is dynamically typed, variables do not have a fixed type and can store different values throughout a program. First, x is assigned the value 10. Later, x is updated to 20. The old value 10 is replaced and x now stores 20. Since Python is dynamically typed, so you can change the type of value stored in a variable like an integer to a string. 4. Multiple variables assignment. You can assign multiple values at once like this, or assign the same value to multiple variables like this. 5. Variable types. Python variables can store different types of data. Let's take a look at them one by one. 1. String. A string is a sequence of characters enclosed in single, double, or triple quotes. Strings are used to store text. 2. Integer. Integers represent whole numbers, positive, negative, or 0. 3. Float. A float is a number with a decimal point or in scientific notation. It can be written in scientific notation using E like this. 4. Boolean. A Boolean represents only two values, true or false. It is mainly used in conditions and logical expressions. 5. List. A list is a collection of multiple values stored in a specific order. Lists can hold different types of data and allow duplicates. Key points. List is ordered and changeable. Can contain different data types. Supports indexing and slicing. 6. Tuple. A tuple is similar to a list but cannot be changed after creation. Key points. Tuple is ordered but immutable, which means cannot be modified. Faster than lists. Useful for fixed data. 7. Dictionary. A dictionary stores data in key-value pairs. Instead of using an index like a list, you use a key to access values. Key points. The dictionary uses curly braces with key-value pairs. Keys must be unique, values can be any type. Fast lookup compared to lists. 8. Set. A set is an unordered collection of unique items. Key points. Set is unordered and does not allow duplicates. Used for fast lookups and eliminating duplicates. And that's it for this section on variables in Python. We covered everything from what variables are and why they're important to the rules for naming them, how to assign and update values, and the different data types Python supports. We explored strings, integers, floats, booleans, lists, tuples, dictionaries, and sets, understanding how each type is used to store and manage different kinds of data. Learning how to work with variables effectively is an essential step in becoming a confident programmer. 1. What is casting? Before we start, let's understand what casting means in Python. Casting is just a fancy word for converting one type of data into another. For example, you may have a decimal number but want it as a whole number. That's where casting to an integer helps. 1. Casting to integer. First, converting a decimal number to an integer. Let's say we have a decimal number 3.9. Python allows us to convert it into an integer using int. What happened? Python removes the decimal part and keeps only the whole number. It doesn't round the number, it just cuts off the decimal part. Even if it's 3.9, Python still turns it into 3, not 4. Next, converting a string to an integer. Imagine you receive a number as text instead of a real number. 10 is a string. If we try to add it to a number, error. Why? Because 10 is text and 5 is a number. Solution. Convert it to an integer using int. Now Python treats it as a real number. This only works if the string contains numbers. Next, converting a boolean to an integer. Python also allows you to convert true-false into numbers. True becomes 1, false becomes 0. This can be useful when working with conditions in programming. 3. Casting to float. If you have a whole number and want to make it a decimal, use float. 5 was an integer. Float 5 converted it to 5.0. The value is the same, but now Python treats it as a decimal. 4. Casting to string. Why convert to a string? Sometimes you have numbers or other data types that you want to convert into string, so you can display messages with numbers, join text and numbers, store numbers as text in databases or files. Python provides a string to convert any data type into a string. First, converting a number to a string. If you have a number and want to turn it into text, use string. 25 is integer. Python converts an integer 25 into a string 25. Now it's a text value, not a number. But why is this useful? Let's see what happens if we try to combine a string with an integer. It shows error. Python doesn't allow you to mix numbers and text directly. Solution. The solution is simple. Convert age to a string. Now it works. 5. Casting to boolean. First, converting numbers to boolean. Why convert to boolean? A boolean, true or false, is one of the most important data types in Python. It's used in decision-making, if statements, and logical operations. Python allows you to convert numbers, strings, and other data types into Boolean values using bool. In Python, any number other than 0 is true and 0 is false. Why? 1 minus 1, 100 are considered something, so true. 0 is nothing, which means false. Next, converting strings to Boolean. Any non-empty string is true, but an empty string is false. Why? Hello and blank space are considered something, which means true. The last one is nothing, which means false. 6. Casting to list. What is a list? A list is an ordered collection of items, changeable, mutable, and allows duplicates. Why convert to a list? To modify items like adding and deleting items. Also to store data in an ordered way. First, convert a tuple to a list. This is an example of converting a tuple to a list using the built-in function list. The tuple has been successfully converted to the list. A tuple is similar to a list but unchangeable. Converting it to a list allows modifications. So now we can modify it, like adding numbers to the list by using append. Next, convert a string to a list. As shown here, each character in the string becomes a separate list element. Why? Strings are iterable, so Python splits each character into an element. Next, convert a set to a list. A set contains unique values but has no order. Converting it to a list assigns an order. Why? Python does not store set elements in a specific sequence. When converting a set to a list, Python assigns an order, but that order depends on how the set was stored in memory. 7. Casting to tuple. What is a tuple? A tuple is an ordered collection that cannot be changed. Why convert to a tuple? To store fixed data that should not be modified. Tuples use less memory than lists, so they are more efficient, useful for data protection. First, convert a list to a tuple. If you have a list but want to make it unchangeable, convert it to a tuple like this. So now you cannot modify it. Error tuple object has no attribute append. Next, convert a string to a tuple. After converting a string to a tuple, each letter becomes a separate element like this. Next, convert a set to a tuple. When it comes to converting a set to a tuple, order is not guaranteed because sets are unordered. 8. Casting to set. What is a set? A set is an unordered collection that does not allow duplicates. Why convert to a set? To remove duplicates from a list or tuple, to store unique values. First, convert a list to a set. This list contains duplicate values. 2 appears twice, 3 appears twice. After running the code, duplicates are automatically removed. So Python removes duplicate values and keeps only unique elements. What if you want to keep order but remove duplicates? Since sets do not maintain order, sometimes you may want to remove duplicates while keeping the original order. You can use a trick with dict from keys. Why does this work? Dict from keys creates a dictionary with unique keys removing duplicates. List converts it back into a list while keeping the order. That's it for this section on casting in Python. We covered how to convert different data types, from numbers like integer and float to strings, booleans, and collections like lists, tuples, and sets. Understanding casting is an essential skill that makes your coding more efficient and flexible. 1. Arithmetic operators. What are arithmetic operators? They're symbols that help you do math, addition, subtraction, multiplication, and so on. In Python, they work just like a calculator. The list shows the basic arithmetic operators. Let's think of using two numbers, a equal 10 and b equal 3. First addition, you simply add two numbers. 10 plus 3 equals 13. Subtraction. Subtracts the right number from the left. 10 minus 3 equals 7. Multiplication. Multiplies two numbers. 10 multiplied by 3 equals 30. Division. Divides the left number by the right and gives you the decimal or float result. 10 divided by 3 equals 3.333 and so on. Modulus. Gives you the remainder after division. 10 modulus 3 equals 1. the remainder is 1. It's useful to check if a number is even or odd. For example, if A is even, it prints even. Exponentiation. Raises the left number to the power of the right number, like A to the power of B. 10 raised to the power of 3 equals 1000. You can think of power like squaring. Floor division. Divides and gives you the whole number. Drops the decimal part. 10 floor divided by 3 equals 3. Only the whole number part is taken. It's useful when you want only the whole number. 2. Comparison operators. Comparison operators help you compare two values. They always give you one answer, true or false. It's like asking Python, hey, is this bigger? Smaller? The same? And Python answers. The list shows the basic comparison operators. Let's stick with A equal 10 and B equal 3. First, equal to. Checks if A is equal to B. So is 10 equal to 3? Outputs false. Next, not equal to. Checks if A is not equal to B. It's true. Greater than. Checks if A is greater than B. It's true. Less than. Checks if A is less than B. False. Greater than or equal to. Checks if A is greater than or equal to B. True. Less than or equal to. Checks if A is less than or equal to B. False. Three. Logical operators. What are logical operators? Logical operators help you check multiple conditions at the same time. They answer true if the condition is right, false if it's wrong. You'll use these in decision making, like should I go outside if it's sunny and warm? The list shows the basic logical operators. Let's keep using A equal 10 and B equal 3. First, and both conditions must be true. The condition is A greater than 5 and B less than 10? Both are true, so output's true. If one is false, the answer is false. Next, or at least one condition must be true. The example says, is A greater than 5 or B greater than 10? A is greater than 5 is true, so the answer is true. Next, not reverses the condition. The example says it's false. Because A is greater than 5 is true, but not makes it false. Four, assignment operators. What are assignment operators? Assignment operators are used to assign values to variables. They can also perform math while assigning, is pretty handy. The list shows the basic assignment operators. First, simple assignment. It just stores the value. Second, add and assign. The example means adds 3 to x. It's the same as x equal x plus 3. Others are the same as add and assign. You'll use this a lot when counting things in a loop or updating scores in games. For example, imagine you're collecting points from a list of scores. Now you have a list of points. The total score starts with 0. Each time the loop runs, it adds the current score to the total. After the loop finishes, you get the total. In this case, the total score is 100. 5. Membership operators. What are membership operators? Membership operators check if a value exists or doesn't exist inside a sequence like list, string, tuple, dictionary, set. It's like asking Python, hey, is this item in the list? And Python answers true or false. The list shows the basic membership operators. If the value exists in a sequence, it answers true. If not, return false. It's very simple. For example, using in and not in with a list, both output true, because apple is inside the fruits list, and banana is not inside the fruits list. Where do you use this? Checking if a user exists in a database, finding a keyword in a message or sentence, validating if an item is in stock, simple searching tasks, and more. 6. Identity operators. What are identity operators? Identity operators check whether two variables refer to the exact same object, not just if they look the same. It's like asking Python, are these two the same person, not just twins? Yes, true. No, false. The list shows the identity operators. If both variables point to the same object, it answers true. If not, return false. For example, using is and is not with a list. Both output true. Why? Because B equal A means B is just another name for the same list. They share the same memory. Even though A and C look the same, they're two separate lists in memory, different objects. So is not returns true. If you want to check the memory, use the ID function. It shows the memory address. And that's it for the section on this topic, Python operators. We covered a lot, from arithmetic and comparison operators to logical, assignment, membership, and identity operators. These are the building blocks you'll use again and again as you write Python programs, so make sure to review them and practice applying each one. One, what is a list? A list is an ordered collection of items, changeable and allows duplicates. In Python, it looks like this. Square brackets mean it's a list. Items are separated by commas. A list is like your shopping list. You can write down items in order like milk, eggs, bread. Later, you can add more, change one, or remove some. Why is a list useful? Because you can store many values in one place. You can access them by their position or index. You can add, remove, or change items anytime. 2. Indexing. Access items. What is indexing? In Python, indexing means picking an item from the list by telling Python which position you want. Let's look at the actual code. To access a specific item, use square brackets and the index number. Remember, Python always starts counting from 0. If the list has 4 items, the highest index is 3. To access the last item easily, instead of counting, you can use a negative index like this. -1 means the last item. -2 means the second last. 3. Slicing. Get part of the list. What is slicing? Slicing means grabbing a portion of the list, not just one item, but a range of items. Think of it like cutting a piece out of a cake. You choose where to start and where to stop. For example, the slicing starts from index 1. It's a banana. Stops before index 3. Important. The end index item is not included. Plus, you can omit start or end like this. If you leave out the start, it starts from the beginning. In this case, indexing 0, 1, 2. Apple, banana, and cherry. If you leave out the end, it goes until the end. In this case, indexing 2 to the end. Cherry, orange, and grape. Furthermore, you can even skip items using a third number called step. In this case, starts at index 0, goes up to 5, jumps 2 steps, so it outputs index numbers 0, 2, and 4. Apple, cherry, and grape. 4. Adding items. Largely, there are 3 different methods. First, append. The most common way is using the append method. Append adds one item to the end of the list. In this case, it's trying to add orange to the fruits list. By using append, orange gets added at the end. Second, insert method. If you want to put an item anywhere, not just at the end, use insert. Insert adds an item at a specific index position. Example. It's trying to add a grape at index 1 by using insert. Let's look at the output. Grape is added at index 1 between apple and banana. Next, extend method. What if you want to add several items at once? Use extend and pass a list. Extend can add multiple items at once. Example, it's trying to add a list with 2 items using extend. The output shows the extend adds y1. Quick summary. Append is used most often. Insert is helpful when you care about the order. Extend is handy for merging 2 lists. 5. Changing items. Think of your list like a to-do list. If your plan changes, you just cross out the old task and write a new one. In Python, you can replace an item by accessing its index. Example, change an item by index. In this example, banana is replaced with grape at index 1. How does it work? Python checks index 1, the second item. Then it replaces banana with grape. Another example is changing multiple items using slicing. You can even change several items at once with slicing. In this example, banana and cherry got replaced by kiwi and melon. 6. Removing items. In Python, you have a few ways to remove things from a list. First, remove. Use remove when you know what item you want to delete. Python searches for that item and removes the first occurrence. Example, there are 2 bananas in the list and you know it is in it. By using remove, the first banana is successfully removed. But the second banana still exists. Don't forget it's able to remove the first occurrence. Second, pop. Pop removes the item at the index you give. If no index is given, it removes the last item. Example, it assigns index 1, then banana at index 1 is gone. Next, remove the last item. This time it doesn't assign any index, and then the last item, cherry, is removed. 3. Delete. Similar to pop, but del is a Python keyword, not a method. Can delete a single item or even a slice of items. In this example, the first item, apple, is deleted. If you want to delete multiple items, you can write like this with slice. 4. Clear. If you want to keep the list but empty it, use clear. Clear removes everything. Empty the list. It's very handy. Quick summary. Remove removes the first occurrence of the value. Pop removes by index or last item if empty. Del deletes by index or slice. Clear empties the whole list. 7. Loop through a list. First, list plus for loop. By using for loop, you can go through each item in the list one by one. This time it reads each item and prints it. Next, list plus for loop using range with index numbers. Sometimes you don't just want the item, you also want to know its index number in the list. That's where this method is useful. First, len fruits gets the length of the list, 3. Range 3 creates numbers 0, 1, 2. I becomes 0, then 1, then 2. Fruits I grabs the fruit at each index like this. 3. Enumerate. Enumerate is a built-in Python function that helps you loop through a list while automatically giving you both the index and the value. Let's look at an example. Enumerate fruits gives you a pair of index value. Index is 0, 1, and 2. Fruit is apple, banana, and cherry. Instead of using range and length, you can use enumerate and make the code cleaner. Also easy to read. This is the summary of the list. We covered these things. Indexing lets you access specific items using their position. Slicing allows you to grab a part of the list by specifying a start and end index. Adding items includes methods like append, insert, and extend to add single or multiple items. Changing items means you can update any item by its index. Removing items provides several ways to delete items using remove, pop, del, or clear. Looping through a list helps you go through each item using a for loop, range, or enumerate if you need both index and value. One, what is a tuple? A tuple is like a list. It's ordered but immutable, which means unchangeable. Faster than lists, good for fixed data. In Python, it looks like this. Uses parentheses instead of square brackets. Think of it like a sealed box. Imagine you pack some items into a box like fruits and then seal the box shut with tape. Once it's sealed, you can't open it and swap items inside. You can't add anything new. You can't take anything out. But you can still look at what's inside the box and carry it around. That's exactly how a tuple behaves in Python. Why use a tuple instead of a list? When you don't want the data to change, it's faster than a list. It's safe. No one can accidentally change the values. 2. Basic operations. Just like lists, you can use indexing, slicing, and looping. But you cannot do changing, adding, and removing items. It shows an error. So you can use it when you don't want to change the data. This is the summary of the tuple. We covered these things. 1. Indexing. You can access items using their position in the tuple. Indexing starts from 0, and you can also use negative indexing. -1 for the last item. 2. Slicing. Just like lists, you can slice tuples using start, end, or start, end step. This lets you get a subset of the tuple without changing it. 3. Looping through a tuple. You can loop through a tuple using for item in tuple to read each item. For I in range len tuple to use index numbers. For I value in enumerate tuple to get both index and value together. Since tuples are immutable, you can't change their contents, but they're great for storing fixed collections of items like coordinates, settings, or constants. One, what is a set? A set is a collection of unordered, mutable, and unique items. In Python, it looks like this. It uses curly braces. Imagine you're collecting stamps and you don't want duplicates. Each stamp should be unique in your passport. That's a set in Python. Why use a set? To remove duplicates automatically. To do set math like union, intersection, difference. When order doesn't matter, only existence. 2. Basic operations. In this set, there are 2 apples and 1 banana. First, when you print a set, duplicates are ignored. Only 1 apple is kept. Next, just like lists, you can use adding, removing, and looping. But you cannot do indexing and slicing since the items are unordered. 3. Math operations. Sets are not just for holding unique items, they also let you do math-like operations. Imagine you and your friend both have a basket. You want to know what fruits you both have. What fruits are only in your basket? What fruits are in either of your baskets? That's where set operations come in. First union. There are 2 baskets. Only the banana is duplicated. If we use union, which combines all items from both sets, removes duplicates automatically, then outputs 3 unique items. 2 intersection, which means what you have in common. Let's think only fruits in both baskets. Intersection keeps only items present in both sets. In this case, it's a banana. It's useful when you want to find common items. 3 difference. What's only in one set? Let's think what's in your basket but not in your friend's. It removes items that appear in the second set. In this case, it's a banana, so it outputs apple. 4. Symmetric difference. Let's think all fruits that are in one basket or the other, but not both. First, it removes common items, then keeps only the unique ones from both sets, so it outputs cherry and apple. Quick summary. Union combines user tags or categories. Intersection finds shared interest between users. Difference, see what's new or missing. Symmetric difference spots differences between two datasets. This is the summary of the set. We covered these things. 1. No duplicates. A set automatically removes duplicate values. Great for keeping only unique items in your data. 2. Adding items. Use add to insert a new item into the set. If the item already exists, nothing changes. 3. Removing items. Use remove to delete a specific item. 4. Looping through a set. You can use a for loop to go through each item. Note, sets are unordered, so the order might change every time. 5. Math operations. Union combines items from two sets. No duplicates. Intersection finds common items between sets. Difference find different items only in set 1 but not in set 2. Symmetric difference find the unique items from both sets. What is a dictionary? A dictionary is a collection which is ordered, mutable, and do not allow duplicates. Key value pairs. In Python, it looks like this. It uses curly braces, key value pairs with a colon, and commas to separate data. So it's like a real-life dictionary. It has words, these are the keys. Definitions, these are the values. Two, accessing values. Let's say you have a mini dictionary. Each item in a dictionary is a key value pair. Key is what you search for. Value is what you get back. To get the value, you put the key inside square brackets. This tells Python, hey, give me the value connected to the key apple. What if the key doesn't exist? If you try to access a key that's not in the dictionary, you'll get an error. To avoid errors, you can use get to safely access a value. If the key doesn't exist, it just gives back none or a default you choose. 3. Adding or changing items. You can add new notes or update existing ones anytime. Let's say you have a dictionary with 2 key value pairs. Now you want to add the student's major. You simply write like this. Now the dictionary adds a new key called major and sets the value to computer science. The second example is that changing an existing value. Let's say the student had a birthday and is now 21. It updates the value of age from 20 to 21. 4. Removing items. Sometimes you might want to take something out, clear everything, or remove a specific label. Python gives us several ways to do that. Let's say you have a dictionary with 3 key value pairs. First pop. It removes the item with the given key and returns the value that was removed. Second del. It deletes a specific key value pair. Now name is deleted from the dictionary. Third, clear. It deletes all items in the dictionary. You end up with an empty dictionary. 5. Loop through a dictionary. Sometimes you want to see all the keys. Look at all the values. Work with both key and value pairs together. Python makes this super easy. First, loop through keys. This gives you just the keys. Use this when you only need the keys. You can also write just like this without the keys method. Second, loop through values. This gives you just the values. Use this when you only care about the values, not the keys. Third, loop through key-value pairs. This is the most powerful and most common. You get both key and value at the same time with the items method. This is the summary of the dictionary. We covered these things. 1. Accessing values. Get values by using the key directly or safely with get. Using get helps avoid errors if the key doesn't exist. 2. Adding or changing items. You can add a new key value pair or update an existing one using the same syntax. 3. Removing items. Use pop to remove a specific item. Use del to delete a key value pair. Use clear to remove all items in the dictionary. 4. Looping through a dictionary. For key and dict keys, loops through all keys. For value and dict values, loops through all values. For key, value, and dict items, gives you both key and value pairs at the same time. What is a string? A string is a sequence of characters, like letters, numbers, symbols, or even emojis. Think of it like a line of text inside quotes. In Python, it looks like this. Strings are always enclosed in single or double quotes. They are anything inside quotes like letters, numbers, symbols, or even emojis. Two, basic operations. These are the basic operations of string. Just like a list, you can do indexing, slicing, and looping through a string. 3. String methods. What are string methods? Think of string methods as built-in tools or superpowers that help you work with text. Let's explore the most useful ones. 1. Lower. This method changes all the uppercase letters in the string to lowercase. It doesn't affect numbers, punctuation, or spaces. Useful when you want to compare strings without worrying about letter case. 2. Upper. Changes all letters to uppercase. Good for emphasis or standardizing text input. 3. Strip. Removes any spaces from the beginning and end of the string. It's very useful when working with user input where people often add accidental spaces. 4. Replace. Searches the string for a specific word or character and replaces it with another. Only replaces exact matches and doesn't change anything else. In this case, Python is replaced with world. 5. Split. Splits the string wherever the separator is. In this case, a space. It turns the string into a list of smaller strings. Useful when processing sentences, CSV data, or forms. 6. Join. The opposite of split. Takes all the items in a list and joins them into one string, using the string before join as the glue. Useful when you want to display lists in a clean, readable format. 7. Starts with. Checks whether the string starts with a given value. Returns true if it matches false if not. Helpful for checking file types like does it start with HTTPS? 8. Ends with. Checks if the string ends with a certain value. Returns true or false. Common use is checking if a file name ends with JPG, PDF, and so on. 9 is alpha. Returns true only if the entire string consists of letters. If there are any spaces, numbers, or symbols, it returns false. 10 is digit. Returns true only if the entire string contains only digits. Useful when checking user input for age, phone number, and so on. 11. Fine. Returns the index number of the first occurrence of a word or character. If the word isn't found, it returns -1. Great for checking where something appears inside a string. This is the summary of the string. We covered these things. 1. Creating a string. You can create strings using either double quotes or single quotes. Both work the same way. 2. Indexing. Strings are ordered, so you can access characters by their position using square brackets. Index starts at 0, and negative indexes count from the end. 3. Slicing. You can extract parts of a string using the start, end, or start, end step pattern, just like lists. 4. Looping through a string. You can loop through each character in a string using a for loop. Use range for index-based looping or enumerate to get both index and value. 5. String methods. Python provides many built-in methods to work with strings. Modify, such as lower, upper, strip, and replace. Split and join, such as split and join. Check content, such as starts with, ends with, is alpha, and is digit. Search, such as find. These methods make it easy to clean, format, and analyze text efficiently. This is the summary of the data structure. We walked through all these things. Each type has its own structure. List uses square brackets. Tuple uses parentheses. Set uses curly braces. Dictionary uses key value pairs in curly braces. String text enclosed in quotes. As for ordered, list, tuple, dictionary, and string maintain the order of items. Set does not maintain order. About indexed. List, tuple, and string support indexing by position. Dictionary is indexed by keys. Set does not support indexing. Next, mutable. List, set, and dictionary can be changed after creation. Tuple and string cannot be changed after creation. Next, duplicates. List, tuple, dictionary, and string allow duplicate values. In the case of dictionary, it allows duplicate values only. The key needs to be unique. Set automatically removes duplicates. Use cases. List is for collections that can grow or shrink. Tuple is for fixed collections like coordinates or constants. Set for storing unique items or doing set-based operations. Dictionary is for structured data with key-value relationships like user profiles. String is for text, messages, and character data. What is the if-else statement? Imagine you're deciding what to wear. If it's raining, you wear a raincoat. Else you wear a t-shirt. That's exactly how Python makes decisions too. It checks if something is true, and then does what you tell it to. If it's not true, it moves to else and does something different. 1. Basic syntax. Here's the structure Python follows. It checks if the condition is true and then do this. If it's not true, it moves to else and do this. Important: Python uses indentation, space, or tab to show what's inside the if or else block. 2. Example. Let's see a simple example. We created a variable called age. We gave it the value 20. Imagine the user is 20 years old. Python reads this as is age greater than or equal to 18? Age is 20, so yes, it is greater than 18. The condition is true, so run this block. It prints you can watch the movie. What about else? Python skips the else part because the condition was true. The else block only runs if the condition is false. 3. Elif. What is elif? Elif stands for else if. It lets you check more than one condition. Think of it like this. If it's raining, you wear a raincoat. Else, if it's snowing, you wear a coat. Else, you wear a t-shirt. It helps your program choose between many options, like giving grades, checking age groups, or picking game levels. Example. Here's the example code. We create a variable called score. The score is 75. Python checks the first condition. Is 75 greater than or equal to 90? Nope, this is false, so Python skips this block. Python checks the elif condition. Is 75 greater than or equal to 70? Yes, it's true. Python runs this line and outputs good job. And that's it for this section on this topic, Python's if-else statements. We've covered how if-else helps your program make decisions, checked out the syntax, and worked through some practical examples. Plus, we looked at how adding elif lets your code handle multiple conditions smoothly. What is a while loop? A while loop is a tool in Python that repeats a set of instructions again and again while or as long as a certain condition is true. The moment the condition becomes false, the loop stops. For example, if the condition is I will eat cookies while there are cookies left. If there are cookies, you eat one. Check again, any cookies left? Yes. Eat another one. Keep repeating until no cookies left. Then stop. That's exactly how a while loop works in Python. 1. Basics. Let's say the goal is to print numbers 1 to 5 one by one. We create a variable named count. Count starts at 1. This is where our counting begins. Python reads this as, hey, keep looping as long as count is less than or equal to 5. If count is 1, 2, 3, 4, or 5, the loop runs. If count becomes 6 or more, the loop stops. While the count is less than or equal to 5, do the action inside the loop. Python prints the current value of count. The first time it prints 1. In the next loop, increase the count. This means count equals sign count plus 1. Every time the loop runs, count gets bigger by 1. Let's see the output. We started counting from 1. The loop printed each number. After printing 5, the count became 6, so the loop stopped. That's how while loops work. They keep running until the condition is no longer true. Important, avoid infinite loops. This is an example of an infinite loop. If the condition never becomes false, the loop keeps running forever. This is called an infinite loop. 2. Break and continue. This is an example of using break. The goal is to print numbers starting from 1 and stop when the number reaches 3. Look at the while true. True means always true. This is called an infinite loop. Normally this loop never stops unless we use a break. So Python will keep running the loop until we tell it to stop. On the first loop, num equals sign 1, so it prints 1. On the second loop, num equals sign 2, it prints 2. It keeps printing the current number. After printing the number, Python checks, is num equal to 3? If yes, the loop breaks, stops. If no, the loop continues. This increases num by 1 every time the loop repeats. Let's see the final output. The loop stops right after printing 3 because of the break. So it works perfectly. Break is like a stop button. It stops the loop when num becomes 3. This is super useful when you don't know how long the loop should run, but want to stop when a condition is met. This is an example of using continue. Num starts at 0. The loop runs while num is less than 5. Num is increased by 1 at the start of the loop. If num equals 3, the continue statement skips printing and jumps back to check the condition for the next loop. If num is not 3, it prints the value. So you can use continue in a while loop when you want to skip specific values or conditions but still keep the loop running. It's helpful when you don't want to process certain items or numbers. 3. While loop with else. This is an example of using else. The goal is to print numbers 1 to 3, and when the loop finishes, print loop finished. At the end, we create a variable x and set it to 1. This is our starting point for counting. Look at the while loop condition. Python checks, is x less than or equal to 3? If yes, the loop runs. If no, the loop ends and the else block runs. If you use break inside the loop, the else won't run because the loop didn't finish naturally. What is a for loop? A for loop is a tool in Python that lets you repeat an action for each item in a group, like a list, a string, or a range of numbers. Imagine you have a basket full of fruits. You want to pick up each fruit one by one and eat it. A for loop helps you do exactly that. It grabs one fruit at a time and repeats your action until the basket is empty. 1. Basics. This is a simple example of for loop. The goal is to go through each fruit in the list and print a fruit. You have a list called fruits. Inside the list, there are 3 items: apple, banana, and grape. Think of this as a basket of fruits. Python reads this like, for each fruit in the basket, do something. The loop automatically picks one fruit at a time from the list. The variable fruit holds the current fruit on each loop. The loop prints this is and then adds the current fruit's name. Fruit is replaced with the actual fruit, like apple. Let's see the outputs. After going through all the fruits, the loop stops automatically. No need to tell it when to stop. 2. Loop numbers. This is an example of using range to loop a number of times step by step. The goal is to print numbers 1 to 5 one by one. The range function generates numbers starting from 1 and stops before reaching 6. So it creates 1, 2, 3, 4, 5. Note, the stop number 6 is not included. Next, start the for loop. Python reads this like, for each number I from 1 to 5, do this. The variable I takes each number in the range one by one. Each time Python prints the current value of I. Let's see the outputs. After printing 5, the loop finishes. Python automatically stops because the range ends. So it's perfect when you want to repeat something a certain number of times. 3. Looping string. This is an example of looping through each letter in a string step by step. The goal is to go through each letter in the word Python and print it one by one. A string is just a bunch of characters grouped together like letters, numbers, and symbols. Here the string is Python. It has 6 letters. Next, start the for loop. Python reads this like, for each letter in the word Python, do this. The variable letter holds the current character as the loop runs. Each time the loop runs, Python prints the current letter. After printing all the letters, the loop ends automatically because there are no more characters. As shown in the outputs, it printed each letter on a new line. 4. Break and continue. First, about break. Break means stops the loop completely. This is an example of break. The loop printed apple. When it found banana, the loop stopped immediately. Grape was skipped. Next, about continue. Continue means skips the current item and moves to the next one. This is an example of continue. What happened? The loop printed apple. When it hit banana, it skipped printing. It moved on and printed grape. So break and continue give you more control inside the loop. This is a summary of the while loop and for loop. Purpose. A while loop keeps repeating as long as a certain condition is true. You use it when you want the loop to continue until something changes. A for loop repeats a set of actions for each item in a group, like a list, a range of numbers, or a string. It's useful when you know how many times you need to loop. Best use cases? Use a while loop when you're not sure how many times you'll need to repeat the action. For example, repeating until a user enters the correct answer. Use a for loop when you know the number of times you want to repeat something, or when you're going through a list of items. Loop control. In a while loop, the loop runs based on a condition that keeps getting checked. In a for loop, the loop runs based on the number of items in the sequence. It automatically moves through each item one by one. Example use. A while loop is great for tasks like checking user input repeatedly until it's correct. For loop is commonly used when looping through lists of data, a set of numbers, or characters in a word. Can you use break and continue? Both while loops and for loop allow you to use break to stop the loop early, or continue to skip to the next round of the loop. What is a function? A function is a block of code that performs a specific task. Instead of writing the same code again and again, you define a function once and reuse it whenever needed. You can think of it like a machine. You give it some input, it does something, and sometimes gives you back a result. For example, a washing machine is like a function. You put dirty clothes, press start, run the function, and get clean clothes. A function in Python works the same way. You run it and it does the job for you. Why use functions? Avoid repeating the same code again and again. Make your code organized and easy to understand. Reuse the function whenever needed. Break down a big program into smaller tasks. 1. Basics. This is how to define a function in Python. You can use the def keyword to define a function. Greet is a function name. You can name it anything. For example, this function is just for saying hello. Welcome to Python. After defining it, you can call the function like this. Then get this output. 2. Functions with parameters. You can pass data to a function. Imagine you need to say hello to different people. Instead of writing every time, you can create a function like this. The name is a parameter, like a placeholder or variable that gets a value when you run the function. Then I call the function with different names and get this result. So this function greets anyone by their name. You just give it a name and it will print hello and name. 3. Functions with return value. What is a return value? A function with a return value gives something back after it finishes its task. Print shows the result. Return sends the result back so you can use it later. Look at the function named add. A and B are parameters for the values you give later. So the function is ready to take two numbers and do something with them. About return A plus B, the return gives back the result. A plus B adds the two numbers. So this line tells Python, after adding A and B, give me the answer back. Next, call the function with 3 and 5. Saves the return value, which is 8, into the variable result. Then print the result 8. Why use return? You can store the result in a variable. You can use the result later in your code. Functions become more flexible and powerful. Finally, important difference between print and return. Print displays the result on the screen. It's just for showing the output. You can't use the printed result later in your code. Return sends back the result to where the function was called. You can store the result in a variable. You can use the returned value for more calculations or processing. And that's it for this section on functions in Python. We covered what functions are, how to define them, use parameters and return values to make your code cleaner and more powerful. Functions are an essential part of coding, and understanding them will help you write better, more organized programs. What is a class? A class is like a blueprint or template for creating objects. Imagine this. You're at a car factory. The factory has a blueprint or a plan to build cars. That blueprint defines attributes or data: color, brand, model, year. Methods or functions: start, stop, honk, and more. In Python, a class is that blueprint. It tells the program what attributes and methods a car should have. Once you create a class, you can reuse the blueprint and create many cars like this. We call these cars objects, also called instances. 1. Basic structure of a class. This is the basic structure of a class. A class usually has class name, the name of the blueprint; constructor, a special function to set up the object's features when created; attributes, the features of the object; methods, the actions the object can do. This is an example of a car class. The class name is car. This is the constructor. It runs automatically when you create a new car. Self-brand and self-color are attributes. Why is self needed? Because attributes belong to the object. Self-brand means the brand of this specific car. If we don't have self, the program won't know which object you're talking about. Think of self like a name tag. Every object gets a name tag when created. Self helps the program know which car's data you are talking about. So you almost always need self inside class methods. Next, start engine is a method. The car can start the engine. The honk is also a method. The car can honk. 2. Create a car object. To create a car object, we can write like this. My car is the name of your car object. You can name it anything. Car class calls the constructor init inside the car class. Toyota and red. These are the values passed to the init method. Now, my car is an actual car with brand Toyota, color red. Now let's use the object's methods. After creating the car object, you can tell it to do things like start the engine or honk. This runs the start engine method inside the class. It uses self-brand and self-color from your car object. It outputs red Toyota engine started. This runs the honk method of my car. It accesses self-brand and prints the sound. It outputs Toyota says beep beep. Why is this cool? Because you can create as many car objects as you want, each with different data like this. They are different cars, but follow the same blueprint. This is a quick summary of important terms. Class. A class is like a blueprint or template for creating objects. It defines what features, attributes, and actions methods the objects will have. Object. An object is an actual instance created from the class blueprint. You can create many objects from one class, and each object can have different data. Init. This is called the constructor method. It runs automatically whenever you create a new object. It's used to set up the object's initial data, attributes. Self. Self refers to the current object instance you are working with. It helps the program know which object's data is being accessed or modified. Attributes. Attributes are the data or properties of an object, like color, brand, model, and so on. They describe the state of the object. Methods. Methods are functions inside a class that describe what the object can do. 3. Class variable versus instance variable. About class variable. A class variable belongs to the class itself, not to any specific object. It is shared by all objects created from that class. If you change the class variable, the change affects every object. Think of it like a rule or fact that applies to all objects. For example, all cars have 4 wheels. It's a common fact, so you can make wheels =, for a class variable. No matter how many car objects you create, they all share this same value. Next, instance variable. An instance variable belongs to a specific object. Each object can have different values for its instance variables. Think of it as personal features unique to each car, like color or brand. In this case, one car is red, another is blue. The color is an instance variable because it can be different for each car. This is a brief summary of the class variable and instance variable. A class variable is shared by all objects created from the class. It is defined directly inside the class. It is useful for common facts that apply to every object of the class. If you change a class variable, the change affects all objects that use it. On the other hand, an instance variable is unique to each object. It is defined inside the init constructor using self. It is used for personal attributes that are different for each object. If you change an instance variable, it only affects that one object and not the others. 4. Inheritance. What is inheritance? And what can you do with inheritance? By using inheritance, you can inherit methods and attributes from the parent class, add new methods unique to the child class, override existing methods to change behavior in the child class. For example, if you have a car blueprint parent class that defines common methods like start engine and honk, EV class, child class, can inherit those methods from the parent class. Also, you can add new methods unique to the child like charge battery. Furthermore, you can override existing methods to change behavior in the child, such as changing the honk sound. Why is inheritance useful? Because you don't have to write the same code again. If you update the parent class, the child automatically gets the update. You can create many child classes from one parent. This is an example of parent and child class. First, create a parent car class which has 2 attributes and 2 methods. Second, create a child electric car class that inherits parent car class. To create a child class, just write a parent class name in parentheses. Now electric car gets everything from parent car class. Also, it has its own function, charge battery. Next, let's create an object from child electric car class and use both parent and child features. Start engine and honk are inherited from parent car class. Charge battery is unique to electric car, so inheritance works perfectly. This is an example of override. You can change the parent method behavior by defining the method again in child class. The child class object outputs Tesla starts silently, no engine noise. Its child class method result. 5. Encapsulation. What is encapsulation? Encapsulation means hiding important data inside the class and controlling how it's accessed or changed. It protects the data by making it private or restricted. Instead of letting anyone change the data directly, you create methods like getters and setters to control the access. Why use encapsulation? Because to protect data from accidental changes, to control how the data is updated or retrieved, to make the program safer and easier to manage. This is a simple example of encapsulation. To create private attributes, add double underscore before the attribute name to make it hidden. To read or update the private attribute safely, use getter and setter methods. Next, if you call the getSpeed method after creating object with Toyota and 100 as attributes, it outputs 100. If you call the getSpeed method after running setSpeed with 120, it outputs 120. But what happens if you try accessing private data directly like this? It shows error, Python blocks direct access to the speed. So encapsulation works correctly. You can use it when you want to hide and protect the data. 6. Polymorphism. What is polymorphism? Polymorphism means many forms. In Python, it allows different classes to have methods with the same name but different behavior. The same method name works differently depending on which object is calling it. Why is polymorphism useful? Makes your code more flexible. makes it easier to add new features, helps write cleaner and more readable code, helps objects act differently even if they share the same method name. Imagine this. You go to a park and there are different animals. Each animal can make a sound, but the sound is different depending on the animal. For example, dog says woof, cat says meow, bird says tweet. Even though you tell each animal speak, each animal responds differently. The action speak is the same command you give to each animal, but the actual sound depends on which animal receives the command. This is exactly what polymorphism means. Same action, different results based on the object. This is a simple example of polymorphism. First, create different classes with the same method name. Next, call the same speak method from different animal objects. To make code simple using a for loop, but you can also create objects separately. Let's check the output. Even though we call speak on each animal, each class runs its own version of the method. This is polymorphism. Same method name, different behavior based on the object. Another example is polymorphism with inheritance. We are combining two things, inheritance and polymorphism. First, create a parent animal class. It has a method called speak. If any child class doesn't have its own speak, it will use this one. Second, create child classes dog and cat. Both dog and cat inherit from animal. Both override the speak method, they change how speak behaves. So now dog says woof and cat says meow instead of animal speaks. Okay, let's check the result. Create objects using a list and for loop. You loop through each animal and tell them to speak. Even though we say the same thing, they answer differently. That's polymorphism with inheritance. Seven, special magic methods. Magic methods are special methods in Python. They start and end with double underscores. Python automatically calls them when certain actions happen. They make your objects behave like built-in types, like strings, lists, and so on. Why use magic methods? To customize how your object behaves. To make your object more powerful and flexible. To make your object work with Python's built-in functions like print, len, and so on. These are the most common magic methods you should know. Let's take a look at this step by step with a sample code. First, an example of using init and str. Init runs automatically when creating a car object and sets up the data. Str controls what gets printed when you do print my car. Without str, it would print something like this. Next, an example of using len. Let's say you want to use len to show the car's name length. The output returns 96 plus 3, the total length of the brand and color. Alright, that's it for this section. Let's quickly review what we learned in this section. A class is like a blueprint or design. It defines what data, attributes, and actions, methods, an object will have. An object is the actual thing created from the class blueprint. You can create many objects from one class and each one can have different data. Attributes are the data or information stored in an object, such as the car's color, brand, or speed. Methods are the actions or behaviors the object can perform. For example, a car can start the engine, honk, or drive. Init. This is called a constructor method. It automatically runs when you create a new object. It sets up the object's attributes, like setting the brand and color of the car. Self refers to the current object you're working with. It helps Python know which object's data you're accessing or changing. Inheritance allows a child class to reuse the parent class's code. The child can also add new features or change behaviors from the parent. Encapsulation means hiding and protecting data inside the class. You control who can read or change that data using getter and setter methods. Polymorphism allows the same method name to work differently depending on the object. For example, different animals have a speak method, but each makes a different sound. Magic methods are special functions like init star or len that Python runs automatically. They make your object behave like built-in types when printed, measured, or compared. And that's it for today's lesson. We explored the essentials of Python basics, from printing and writing comments to working with variables, casting, and operators. We also looked at important data structures like lists, tuples, sets, dictionaries, and strings, and covered control flow using if-else statements and loops. We wrapped it up with functions and an introduction to classes. Learning Python is a powerful step toward building real-world applications and solving problems with code. The basics you learned today are the building blocks for everything you'll create. Keep practicing each concept by writing your own mini projects or experimenting with small challenges. You'll be amazed at how quickly your skills grow when you apply what you learn consistently. Okay, thanks for watching today's lesson on Coding Fab. I hope you found these tips useful and feel more confident. Remember, practice makes perfect, so try using these tips in your project. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and subscribe for more Fab coding lessons. Until next time, keep practicing and stay Fab.